All right, we're going to take a look at some advanced factoring questions here. So for this first one here, we are given 4a squared times c squared minus a squared minus b squared plus c squared, the entire expression also squared. So right away, what you want to do is you want to go through your factoring techniques. You always want to look for a GCF first. As I look through this, I do not see a GCF here, a common number or a common factor I can take out. I do see a subtraction symbol, and I see powers of 2 here, so I want to see if I can set this up as a difference of squares. So if you take a look here, I can rewrite this expression as 2ac all to the power of 2 minus, this expression is actually already to the power of 2. So right away, I can do my difference of squares formula. If you remember, your difference of squares formula is expressed as x squared minus y squared is going to equal x minus y times x plus y. So in this case here, this is now my x, and this entire expression is now my y. So I'm going to go ahead and apply my formula here. This is going to end up being my x here, so this is going to be 2ac is my x minus my y. Don't forget to put that y in brackets. You have to distribute that minus sign into that. So x minus y times x plus y. And I didn't really need the brackets around the second expression here. So I will drop it in the next step. So again, now I'm going to distribute that minus sign into the brackets, giving us negative a squared plus b squared minus c squared. And then again, this will be 2ac, and I can just drop those brackets, giving me a squared minus b squared plus c squared. So continuing on here, I see that I have 2ac, I have an a, and I have a minus c. So it would be nice if these kind of connect together in some way, and those can factor, right? Because what I'm thinking is, you know that x minus y squared is going to equal x squared minus 2xy plus y squared. So I sort of have that going on in this expression, and if we look in the other expression, I also have it going on here. I have all the elements of that sort of pattern, just to make sure the minus signs line up. So let's go ahead and rearrange this. So this is going to be b squared minus, I'm going to factor that minus sign out, so it's going to be a squared minus 2ac plus c squared. And here I'm going to just rewrite this as a squared plus 2ac plus c squared. I'll put the minus b squared in the back now. All right, let's take a closer look here. So I'm kind of grouping these together, right? Likewise on this expression. So the idea here is I had to factor the minus sign out, right? Because I've got these 1, 2, 3 terms. To put them together, I have to factor that minus sign out, so we actually get it in the form we see here with a positive sign in front. So I had to factor that out. That's what happened here. Now that is exactly equal to a minus c quantity squared. And this will be a plus c quantity squared. So I can go ahead and make that adjustment. This will be b squared minus a minus c quantity squared times this one will be a plus c squared minus b squared. So now I'm making my way through this problem. You can see here I've got more work to do, but it's looking simpler with each successive step. You can see here I've got b squared minus a minus c quantity squared times a plus c quantity squared minus b squared. So I can do my difference of squares formula a second time here, where this is my x and this is my y. So this becomes x minus y times x plus y times, and do my difference of squares formula again. So it's going to be x minus y times x plus y. All right, we're almost there, having this fully factored here. If we take a look at this problem, I can now distribute my minus sign, to which I get b minus a plus c times b plus a minus c times a plus c minus b times a plus b plus c. And now we have our expression here fully factored. None of these factors are the same. These are all unique combinations of the AC and B values based on their signs. So I can't really combine any of these together, and now this is fully factored. So turns out that if someone asked you to factor this expression here, doing difference of squares 1, 2 times with some creative factoring techniques here, we can get our expression fully factored. All right, let's take a look at another problem. I want to be able to factor this expression. First, we want to look for a GCF. If I look at this expression here, I do not really see a GCF, a common factor throughout. I do see an a minus 2b here, and I do see that I can do a difference of squares on this. Now, typically this does not work. Like just doing a difference of squares on a chunk, you have to have that same factor occur here, and it actually does. If you take a look here, this is a squared minus 2b quantity squared if I want to use my difference of squares formula. And using my difference of squares formula with a as my x and 2b as my y, this becomes a minus 2b times a plus 2b. And then I have this plus a minus 2b left over. Now the advantage to this is now I have a common factor. These are common in both. So this I can factor out. I get a minus 2b, and to which I'm left with a plus 2b plus 1. And don't forget, when you factor something out, you're dividing. So that plus 1 came about from taking the a minus 2b divided by a minus 2b. A minus 2b divided by a minus 2b. Divide that out, you get a 1. That's where the 1 came from. And then if I take this expression here and divide out the a minus 2b, you'll be left with a plus 2b, which is what I have. So this one was a bit quicker, but still a interesting observation to make to get to that problem. Applying difference of squares to kind of the front end of this expression, and we were lucky enough to have a common factor in both. Allowed me to factor it out and factor the expression. All right, let's take a look at one more. So for the last problem here, similar technique that we want to apply here. So for this one here, again, I have an a squared minus 4 here, and I like to be able to get that here, and I kind of see the a squared minus 4 here. So if we factor out an x cubed out of the front here, I end up getting the a squared minus 4 that I want, and then I have this a squared minus 4 from before, and you'll see here I now have a common factor in both. I have an a squared minus 4 in each, so I can factor out the a squared minus 4, and I'm going to be left with x cubed plus 1. So right away you can see I can use my difference of squares form and then break this up into a minus 2a plus 2. And I'm left with x cubed plus 1. Now if you haven't learned this here, this is my sum of cubes formula. I'll link a video in the top right hand corner. If you haven't learned the sum of cubes formula, you can apply that. But this is what I have here. I have my sum of cubes formula. So again, I can rewrite this 1 as 1 cubed, and this becomes the sum of cubes formula. So this will factor into a minus 2 times a plus 2 times, in this case here, we're going to end up getting here x minus 1 times x squared plus x plus 1. And now my expression here is fully factored. So right here I applied my sum of cubes formula. And you can go ahead and see the linked video there on sum of cubes if you want to check that out if you haven't learned it. But this product here is equivalent to what I have above. All right, this concludes today's lesson. Thank you.